In this video, we're going to be talking about solubility equilibrium in KSP. So this problem is number 12 on page 446. So the problem states, cadmium 2 chloride is added to a solution of KOH, potassium hydroxide, with a pH of 9.62. So the KSP of CdOH2 is 2.5 times 10 to the negative 14. So basically this problem is all manipulating the KSP equation. So the first thing we know, and the problem is given, is that the pH is equal to 9.62, so we just find the pOH, which is equal to 4.38. So when we do 10 to the negative 4.38, we get 4.1687 times 10 to the negative 5 molar of OH minus. So now we have the KSP equation right here, which is CD2 plus times OH minus squared, because you have the 2 here. So that's equal to the KSP, which is 2.5 times 10 to the negative 14th. So if we manipulate this equation a little bit, because A is asking for the concentration of CD2 plus, we get that is equal to 2.5 times 10 to the negative 14th over OH minus squared. So if we just plug that in, which is OH minus squared, we get the concentration of CD2 plus. So that's all for part A. So part B gives you the concentration of CD2 plus and is asking for the concentration of OH minus. So for that, we also need to write out the KSP equation, which is CD2 plus times OH minus squared, again, because of the 2, and 2 is equal to 2.5 times 10 to the negative 14th. So we may plug in that 0.0013 from the givens in part B. We just have to manipulate the equation, so we get the concentration of OH minus is equal to the square root of 2.5 times 10 to the negative 14th over 0.0013. So when we do that in our calculators, we get the concentration of OH minus is equal to 4.3852 times 10 to the negative 6. Oh, and the answer to that would just be, it asks for the pH, so the pOH would be 5.358, and the pH is 14 minus that, so just 8.64. So for part B, it asks for the percent of OH minus left from the original solution. So first we know that the OH minus from part A, which is the original solution where the pH is 9.62, we have that, so we can just find the OH minus, which is what we did in part A, and then the OH minus in part B is what we did, so 4.38529 times 10 to the negative 6. So now we have to find the percent of OH minus. So that's the final, or what's left over the total, which is part B over part A times 100, because it's a percent. So we're just going to plug in those values, and that gives us 10.52% of OH minus left from the original equation. Thank you for watching, and I